Yes, ma'am.
Okay, great. So I hope all of you are students who have been attending the previous sessions. Is there someone who is a new student over here? If there is someone, they could please raise their hand or unmute or type in the chat box. I believe all of you are students who have been attending the previous sessions and you have all the important links, namely the YouTube channel, the Google Drive link, and the Discord server. So I will not put them up again over here. I hope all of you already have it. So if someone does not have it, you please type in the chat box, then I will provide it if you do not have it. But I'm assuming that all of you have all the important links with you. So we will start with today's session, and today's session we will actually review one of the questions from the previous session. So this was one question from mathematical physics, which we did in the previous week, which had some issue regarding the solution to it. So I believe someone, I guess Rituraj had very rightly raised this query in the last week regarding this question on singularities. So we had to classify whether a singularity was a simple pole or a pole of certain order n. So this was this question on complex analysis where we had to identify the singularity. So let us just review this question and then I will provide you with the correct solution. So this is what we did in the last class. So the question is, which of the following statements is true for the function fz equals to z sine z over z minus pi whole square? So now we saw that these were the four options. The first option said that fz is analytic everywhere in the complex plane, which clearly is not the case because of the denominator going to 0. Then the second statement said that fz has a 0 at z equal to pi. Again, this is not a correct statement. The correct statement would be that fz has a 0 at z equal to 0. And then there was confusion regarding which of options C and D should be correct. Option C says that fz has a simple pole, has a pole of order 2 at z equal to pi, and option D says that fz has a simple pole at z equal to pi, and we are supposed to select between these two options. So last class we had said that this option C should be the correct option, but as Rituraj had correctly pointed out, this is not the correct option. The correct option is option D, which is that fz has a simple pole at z equal to pi. And why so? We can check that. So in order to check that, we need to note that the function that we are given, so this is the function. Now this function is of the 0 by 0 form at z equal to pi. So 0 by 0 form as z tends to pi. Why? Because sine of pi is equal to 0 and z minus pi is equal to pi minus pi, which is also 0. So it is like a 0 by 0 form. So now in this situation, we can't just conclude by looking at the function. We need to go for what is the series expansion. So we need to find out the series expansion of f of z. And how we do the series expansion of f of z? Well, there can be two methods. I will discuss both of them with you. So the first method of finding the series expansion is as follows. So we can substitute u as z minus pi. So by substituting this, we get what? Z is u plus pi. So then what our sine z will become? Sine z equal to sine of u plus pi, because z is now u plus pi. So this is what we know, that sine pi plus something is negative of sine of that something. So negative of sine u. And we know this Taylor series expansion for sine u. We know that we have all learned it in school. So this is as follows. And so on and so forth. Now we will substitute back the expression for u. So this gives us, now u is what? Z minus pi. So this is Z minus pi minus Z minus pi cube over 3 factorial and so on and so forth. So this is the expression for sine z. Another way to find the expression for sine z would be as follows. This is not just another, this is like same method only, but we are just using the Taylor series explicitly. Here we have used by memory the series expansion for sine u. Here we will actually find out the series expansion. So what we want to find out sine z about the point z equal to pi. So what we have from Taylor series, so from Taylor's expansion, so from Taylor's expansion, we know that fz equal to f about the point a, so a here is pi, plus f prime at a, z minus a, plus f double prime at a over 2 factorial z minus a whole squared, plus the third derivative, and so on and so forth. Okay, so now our function, this is sine z is the function that we are taking for now, for the time being. So we want to find out the expression for sine z about the point z equal to pi. So we know that sine of pi is what? It is 0. So the first one is 0. Then we have derivative of sine. So derivative of sine is what? It is cos. And then when you differentiate cos again, you get minus of sine. Then minus of sine you differentiate, you get minus of cos. Then minus of cos you differentiate, you get sine, and then further you differentiate, you get cos, and this keeps on repeating. Where S over here I'm using as shorthand for sine, and C I'm using as shorthand for cos. So derivative of sine z is cosine z, and cosine at z equal to pi is minus 1. So minus 1 times z minus a, and then second derivative, that means minus of sine pi, so that is 0. Then we get what? We get come to the third derivative, so that is negative of cosine at pi, so that is plus
z minus pi.
Sorry?
There will be z minus pi.
Yeah, it will be z minus pi because a is equal to pi. Right now I'm just writing the most general one, but we can put it here. So z minus pi, and then the second derivative is 0 because at sine of pi we have 0. Then we move to the third derivative. So third derivative means negative of cosine of pi, so that is plus 1. So plus 1 times z minus pi cubed over 3 factorial, and then you can continue in this scenario. Then the next term would be 0 because sine, and then the next term would come with a minus 1 because it is cosine. So like this, and then you can keep on continuing as much as you feel like. So let me just rewrite it once again. So my series becomes for sine z. Note that this is all for sine z right now. So this is same as what we obtained earlier. So these two series for sine of z about z equal to pi are same. Now we come back to our original function. Original function is what? Z sine z over z minus pi whole square. And we need to look at z equal to pi. About this point we need to focus. So this series then becomes z over z minus pi whole squared times sine z. And what is my sine z? I know sine z, we have just found the expression for sine z. So that is minus z minus pi plus z minus pi whole cube over 3 factorial minus z minus pi to the power 5 over 5 factorial, so on and so forth. So let us now just cancel out a few terms in the numerator and denominator. So you see that there is z minus pi in the numerator and z minus pi in the denominator. So these factors will cancel out. So when you cancel out the factors, what do you get? So you see that here there is z minus pi, here there is z minus pi. So you will cancel out these factors. So you will get, first term would be negative of z over z minus pi. Then the second term would be z times z minus pi over 3 factorial, because this is z minus pi squared and this is z minus pi cubed. So it will cancel, giving you z minus pi in the numerator. Then you would get minus z times z minus pi to the power 3 over 5 factorial, and you can keep on adding more and more terms. Now you focus, now you need to find out the singularity. And you see that the singularity is contributed only by this first term over here. So just this term contributes to my singularity. All of this part is analytic. There is no singularity. So this part is analytic, no singularity. And this part contributes to your singularity. So what you see that in the denominator you have z minus pi to the power 1. So as a result of this, z equal to pi is a simple pole, because you have just z minus pi to the power 1 in the denominator. Had it been let's say minus z over z minus pi squared, had it been this term, so this is as a side note, this is not for the question, but had it been this term, then you would have said that z equal to pi is a pole of order 2. So this is an important question in that sense, to be very clear as to how we are finding out our poles and simple poles and poles of order n and various other singularities. So I had also made this mistake just by looking at the function. So please make sure that you people do not make such mistakes in your exam. So when you have a question, you need to be very precise and very clear as to which point you are looking at. And at that point, you should be checking what part goes to 0, what part becomes a singular part, and so on and so forth. So if you look over here, z equal to 0 would have been simply 0, but z equal to pi, one needs to be a little bit careful over here, because both the numerator and the denominator are going to 0. It's like this 0 by 0 form. And when you encounter such a situation of indeterminate or 0 by 0 kind of form in which both the numerator and the denominator are going to 0, in such a situation, you should go for the series expansion. So when you have this 0 by 0 form, you should definitely go for series expansion. And in the series expansion, then you can have a look at the terms. So once you get the series expansion, you check out which terms are analytic. So if the terms are analytic, then they will not contribute to any kind of singularity. And whatever part is singular, you need to check what the order of pole is that in that term. So this is how you would do it. So be very careful in these kind of questions, in which you might be tempted to just tick the answer as quickly as possible just by looking at the function. But in reality, it requires a little bit more effort in the terms of series expansion. So this was a clarification from the previous week. Thank you, Rituraj, for pointing this out in the last class. So yeah, it's good that people are paying attention and people are asking questions and raising issues. So that actually helps clarify a lot of concerns and a lot of queries of everyone, including me. So yeah, so that is from the previous week. Now we will move to the current week's session, current week's questions. So yeah, this has taken quite some time, but it was important to clarify this thing so that you people do not make this mistake ever again. So now we will move to the current week. So as always, we will start with a few general aptitude questions and then move over to electromagnetic theory. So the first question from general aptitude is, the radius as well as the height of a circular cone increases by 10%. The percentage increase in its volume is, and you need to select what is the correct answer. What is the percentage increase in the volume when the radius and height are increased? So what we know, that volume of a cone, is given as follows: 1 by 3 pi r square h. So now my new radius is becoming 10 times more. So 10% more. So this becomes 1.1 times the old radius, and my new height is also increasing by 10%. So this is what my new radius and new height are. So as a result, my new volume becomes as follows. We will use new radius and new height. So this is 1 by 3 pi r squared h times 1.1 cubed. Now 1.1 cubed, one can put in the calculator and find out that this is 1.331. So the increase in the volume is V new minus the old volume. So that is 1.331 minus 1. So the percentage increase is by this factor, and this factor is how much? This factor is 0.331. So this gives you 33.1% in terms of percent increase. So this is the important factor. So this is the factor which tells you how much increase in volume is happening. So this is increase in volume. So very simple question, answer is 33.1. So moving over to the next question. 5 numbers 10, 7, 5, 4 and 2 are to be arranged in a sequence from left to right following the directions given below. So we have a set of rules to arrange these 5 numbers. First rule says no two odd or even numbers are next to each other. Next rule is that the second number from the left is exactly half of the leftmost number. And the third one is that the middle number is exactly twice the rightmost number. So we need to find out the sequence. So sequences of 5 numbers. So we need to fill in these blanks with 5 numbers. This is my rightmost number, and this is going to be my leftmost number, and this one over here will be my middle number. And how many numbers we have? We have 5 numbers, out of which 3 are even, 10, 4 and 2, and 2 are odd. Odd numbers are 7 and 5. So since 3 even numbers are there, and this means that right, left and middle are even. Why? This is by rule 1. This is by rule 1, which states that no two odd or even numbers are next to each other. So you cannot have 2 even numbers side by side. So even numbers need to be separated by odd numbers, and odd numbers need to be separated by even numbers. And since you have 3 even numbers, that means you need to separate them by odd numbers. So the only possible way is to keep the even numbers at the left, middle and right blanks. So that means So this means that the second from right, so the second from right number, this dash, so this dash, we need to find this dash is second from right. So second from right is going to be what? Is going to be odd. Again, because we have uh 5 numbers, and we need to separate even and odd so that they are not next to each other. As a result of this, we need to keep even numbers at the left, right, and middle. So this number is even, this number is even, and this number is even. So these numbers will be odd and odd. So the second from right needs to be odd, and the only odd option in this question is 7. But let us find out the entire sequence, because had there been options given 7 and 5, then you would be confused as to which is the correct option. In that, we need to find out the complete series. So what does rule 2 say? Rule 2 say that middle number is, sorry, this is rule 3. Rule 3 says that middle number is 2 times the right number. This is by rule 3. So this means that middle, which is an even number, is 4, and right, which is also an even number, will be 2, because out of 10, 4 and 2, only 4 is 2 times of 2. So that means we have found out this number. So this middle number is 4 and this right number is 2. Now let us come to rule number 2. So rule number 2 says that second from left is half of the leftmost number. So second from left is an odd number. So second from left is odd and half of leftmost is even. And so this gives you what? This gives you that this is only possible if you have these numbers. That is, second from left is 5, and then 5 is basically half of 10. So this is how you will get these numbers. So that means this number is 10 and this number is 5. It satisfies my rule 2. So this is from rule 2. And then what you are left with is you are left with 7 in this blank from second from right. So this is the complete sequence. Now you have the complete sequence, and any kind of question you get from this complete sequence, you can answer that. So next question, now some English language questions. So until Iran came along, India had never been dash in Kabaddi. This is like very simple, very trivial. The option is A. India had never been defeated in Kabaddi. So means Kabaddi is a game originated from India. So India is pretty good at Kabaddi, but Iran has also of late started performing well in Kabaddi. So if you people follow Kabaddi, you would be knowing this. So India is definitely very good in Kabaddi. And now countries like Iran are also doing well in Kabaddi. So next question. This is the comprehension type question. So the passage is given and you need to comprehend that passage and summarize it in a single sentence. So the question says, since last 1 year, after a 125 basis point reduction in repo rate by the Reserve Bank of India, banking institutions have been making a demand to reduce interest rates on small saving schemes. Finally, the government announced yesterday a reduction in interest rates on small saving schemes to bring them on par with fixed deposit interest rates. The question is, which of the following statements can be inferred from the given passage? And the statements are, whenever the Reserve Bank of India reduces the repo rate, the interest rates on small saving schemes are also reduced. Next statement is, interest rates on small saving schemes are always maintained on par with fixed deposit interest rates. The third statement says the government sometimes takes into consideration the demands of banking institutes before reducing the interest rates on small savings schemes. And the fourth one says a reduction in interest rates on small savings schemes follows only after a reduction in repo rate by the Reserve Bank of India. Now, this is a comprehension question based on some financial schemes, and I have no idea about what financial schemes are, and I have really no idea about all these money related business and all this interests and all these repo rates and whatever. But our aim is not to get expertise in this financial stuff. Our aim is to understand this passage, comprehend it, and select the correct option which matches closely or the which is like basically a correct interpretation of the given passage. So, the correct interpretation of the given passage is statement C right here, which says that the government sometimes takes into consideration the demand of banking institutes before reducing the interest rates on small saving schemes. Now, if you look at the other options, let's say option number D. So, option number D says that a reduction in interest rates on small saving schemes follows only after a reduction in repo rate by the Reserve Bank of India. Now, this is a true statement. This true statement has been mentioned in the passage. But if you look at the passage closely, you realize that the passage is focusing on these banking institutes which are making a request, which are demanding that the Reserve Bank of India listen to their request, listen to the demand, and reduce the interest, the repo rate interest rates. So, even though option D is a correct statement, it's factually true, but it is not the most correct interpretation of the given passage, because the given passage is clearly putting significant stress on these banking institutes. So these banking institutions over here, so these banking institutions which make a demand or which request the Reserve Bank of India to listen to their concerns and then bring down the interest rates. So you need to take into consideration this, and that's why option C is the correct option, which takes into consideration the demands of banking institutes. So even though other statements might be correct statement, they might be factually correct, but they might not, but they would not be the most correct interpretation of the passage. So you need to be very careful in these kind of questions. You might think that this is a factually correct sentence or a factually correct statement, but it may not be what you can infer from the passage. So you need to pay attention to these comprehension. So next question, again a very simple question. So it says that in a country of 1400 million population, 70% own mobile phones. Among the mobile phone owners, only 294 million access the internet, and among the internet users, only half buy goods from e-commerce portals. So what is the percentage of these buyers in the country? So percentage of these buyers meaning the e-commerce portal users. So we are told what? Internet is used by 294 million people, and half of these, that means half of 294 is what? Half of 294 is 147. So half of these use e-commerce portals. So percentage of people using e-commerce is what? It is basically 147 million. These are the people using e-commerce divided by the total population, that is 1400 million into 100. So that is for percentage. So what you get is so 10.5% people use e-commerce portals. All the other information that they have given, 70% use mobile phone, this fact is basically not needed in this question, because we are clearly given that 294 people access the internet. Had it been given that out of the 70% who use mobile phones, let us say 30% use internet, then we would have to find out the 30% of 70%. Otherwise, that fact is useless. But still, if you want, so 1500 million is the total. 70% of this is mobile phone users. So that is 0.7 into 1400 million, which is 980 million. So 980 million people use mobile phone, and then 294 million people use internet, and 147 million people use e-commerce. So this completes the section on general aptitude. Now coming over to electromagnetic theory. So this is a statement, this is a question, two questions based on the following statement. So that's why the statement is written over here, and the subsequent two questions follow from this statement right here. So the statement is, a plane electromagnetic wave has the magnetic field given by the following expression, where magnetic field as a function of x, y, z and t being time and x, y, z being space coordinates, is given by b naught sine x plus y k over root 2 plus omega t in the k cap direction. So k cap direction is along the z axis. So k is the wave number, and I cap, j cap, k cap are unit vectors in x, y and z directions. So we need to find out the electric field corresponding to the wave given above. So electric field is given as follows, and if you flip the order, then this becomes like this. So this is your expression for electric field for plane electromagnetic waves traveling in free space. You have this expression. So now what we need to we basically need to simply find out this cross product, and from here we know the direction of k, because this is nothing but k dot r. So k dot r is k over root 2 x plus y. So this gives you, basically from here you will get the direction. Your k direction is I cap plus j cap over square root 2. So this is the k cap direction that you would have, k cap direction. And if you multiply this with the wave number, then you get the k vectors. So this is k cap, and k would simply be k times, so k over root 2 I cap plus j cap. Okay, and r is nothing but x I cap plus y j cap. So r is nothing but x I cap plus y j cap, and then you see that doing k dot r, you will get this term over here. So you get this k vector. Then coming back to this electric field, this is minus c over k. Then k vector we just found out is minus k over, sorry, is k over root 2 I cap plus j cap. I'm running out of some space over here, so I will have to cross product. Let me write it down below. Cross product b naught. So this is k cross b. B is b naught sine and this b vector is in the k cap direction. So this is your electric field, And then when you do these cross products, what you get CB naught, sine term remains as it is. And the direction is basically, direction is 1 over root 2 times I cap and then j cap k cap cross product, that will so like this. So I and j and then cross product with k you will take and then putting in the proper signs. So this is what you will get as the expression. So this is the expression that you have. Sorry, this is getting too much cluttered over here. So this is the expression of the electric field. So the important thing is that you need to know this. So this is how you would find electric field from the magnetic field by using this expression, and then when you substitute everything you will get the correct answer. So the correct answer, what is the option? Option A. So option A is the correct option in this case. So yeah, people have rightly written in the chat box that option A is the correct option. So nice. Now we move to the next question. So this is also based on this previous part. So it is not completely separate. So this says that we need to find out the average Poynting vector. So Poynting vector is what? Poynting vector is E cross B over mu naught. So you just found out E over here and you were already given your B. So you can do that E cross B. So E cross B. So E is what? C B naught. This is my E. E and cross product with B. B is what? B is simply B naught sine x plus y in the k cap direction. So this is my Poynting vector and then divided by mu naught. So what this gives me? This gives me C B naught squared over mu naught. Sine squared x plus y k over root 2 plus omega t. And then we need to take cross product of this vector times k cap. So if you do the cross product of I cap minus j cap over root 2 cross product with k cap direction, then what you get? You will get I cap cross k cap is minus j cap and j cap cross k cap is I cap, and then minus sign is there. So minus j cap minus I cap over root 2. So this is the direction. So minus j cap minus I cap over square root 2. So this is my Poynting vector, and we need to find out the average Poynting vector. So average Poynting vector is time averaged. So C B naught squared over mu naught, these are constants. So time averaged of sine squared x plus y k over square root 2 plus omega t in the direction. So let's take minus sign common in the direction I cap plus j cap over square root 2. Now average of sine squared omega t is half. So we know that average of sine squared omega t is half. So from that you will get 1 by 2. So the correct option would then be, let us see which is the correct. This is the correct option. So it is in the I cap plus j cap direction. Minus sign is there over here, and then the sine square will give you a value half when you take the average. So the correct answer is D. And how you find out the average of sine squared omega t? That is very simple. Average of sine squared omega t, you will do 0 to t of sine squared omega t dt over 0 to t of dt. Now the sine squared omega t you can write as 1 minus cos 2 omega t divided by 2 is dt. And then you see that this cosine will integrate out to 0 because it is 50% of it is above the axis and 50% of it is below the axis. So that will integrate out to 0 and this will give you 1 by 2. So this is how you would find out the time averaged of any function, not just sine squared omega t. And when you actually find out the time averaged of sine squared omega t in this manner, you get half. So that's how we put half over here and we get the average value of the Poynting vector. So next question. The space-time dependence of the electric field of a linearly polarized light in free space is given by x cap E naught cos omega t minus z, where all these values represent the standard terms. E naught is amplitude, omega is angular frequency, k is wave vector. Then we need to find out time averaged energy density. So again, this is very simple because energy density is energy density associated with the electric field is half epsilon naught E squared. So this will give us half epsilon naught E naught squared cos squared omega t minus kz, and time averaged, so half epsilon naught E naught squared is constant. So time averaged of cosine squared omega t minus kz, and this also is half. Again, using the same procedure, you would find out that time averaged of even cosine squared omega t is half. So then you would get half here, that means 1 by 4. So someone has written as option B in the chat box. So no, option B is not correct. You need to find out time averaged, and this time averaged of cosine squared will contribute to another half factor. So what you would get is 1/4 epsilon naught E naught squared. So I hope now it is clear. So you need to be careful with this time average. So it is asking you time average, it's not instantaneous. So that is how you time averaged of sine squared and cosine squared, both are half. So cos squared omega t and sine squared omega t both give you half. And how you would find out, you would say this cos squared omega t is 1 plus cos 2 omega t by 2, and then you would do this same procedure as we did over here to find out the average for sine squared omega t or cos squared omega t. And again, cosine would...
in this question, amplitude is 2 E naught.
Amplitude is not 2 E naught. Where 2 E naught?
2 E naught cos omega t minus
No, that is x cap. X cap E naught cos omega t. Sorry, I think my handwriting was a little bit bad. X cap, that's the direction. So amplitude is simply E naught. Yeah, had it been amplitude is 2 E naught, then you would have 4 E naught squared, and then stuff would cancel from the numerator and denominator. So had it been 2 E naught, then you would have basically 1/2 epsilon naught 2 E naught squared, and then half from the time averaged, and this would give you, so stuff will cancel out, giving you epsilon naught E naught squared. So had it been 2 E naught, then the option C would be correct, but that is not the case. So yeah, this is the correct answer. And then let us move ahead. So next question is again quite simple. It says a plane electromagnetic wave traveling in free space is incident normally on a glass plate of refractive index 3/2. So if there is no absorption by the glass, its reflectivity is, and we need to find out its reflectivity. So no absorption means no loss is being happening in the glass. It is only reflecting part of it and transmitting the remaining part of it. It is not losing any intensity by absorbing. So no absorption means that there is no loss in that sense. So reflectivity is given as follows, where N1 and N2 are the refractive indices of the first, that is the incident medium, and the second medium respectively. So N1 is the first medium, that the medium in which the light is initially traveling in, and N2 is the second medium that the light enters after refraction. So, and these are the refractive indices of these media. So first it is traveling in free space, that is the refractive index is 1 for free space N1 equal to 1, and this N3 by 2 is N2, refractive index of glass. So 1 minus 3 by 2 over 1 plus 3 by 2 whole squared. So this is minus 1 by 2 over 5 by 2 whole squared. So this is minus 1 over 5 whole squared, which is 1 over 25, which is 0.04, that is 4% reflectivity. So 4% reflectivity, and remaining part is being transmitted. So if 4% is being reflected, then 96% is being transmitted because there is no absorption. So we have that no absorption. So what so reflectivity and transmittivity, they add up to 1. So this will give you transmittivity is 96%. And finally, the last question, the electric and magnetic field E and B respectively corresponding to the scalar potential phi equal to 0 and vector potential A is equal to I cap T Z are, we need to select the electric and magnetic fields. So now we know that electric field is negative gradient of potential, and when there is a vector potential, then this is the expression for electric field. So in electrostatics, we have simply E is negative of gradient of phi, but when you have time varying fields, so fields varying in time and magnetic field having a vector potential which is varying in time, then you would have this extra term from the magnetic vector potential. And B is nothing but del cross A. So you can find out, so electric field is negative of gradient phi, so that is 0, and then negative del A by del T. So del A by del T, A is given, so that is minus I cap Z. So that's the electric field, and magnetic field is curl of A, so del cross I cap T Z. So T is constant, so you can take it out. So T del cross I cap Z, and this will give you simply del cross I cap Z is going to give you J cap, and then T is there. So the correct option in this would be this. E is minus I cap Z and B is J cap T. So this is the correct option, option D. So this solves this current session. So in this session, we discussed some general aptitude questions, some electromagnetic theory questions, and most importantly, we revisited one question from the previous week, and we rectified one error that we had made in the last week. So this rectification of the error is very important, and you should also be very careful. You people cannot make such mistakes. So yeah, so this is all for today's session, and once again, thank you for pointing out this error of the last week so that we could correct it this time. So next week